Okay, hi you guys, this is problem number 2, so make sure you click into problem number 2 on your tabs. So first thing we need to do is populate our data. So we want to find the natural log of concentration. Oops, I forgot my parentheses. Natural log of concentration. And I'm going to bring that down. And I'm going to work with my significant figures. And I also want my 1 over concentration data. And I'm going to bring it down. Okay, so your data should look like mine at this point. So next we want to set up our 3 graphs. So I'm going to do time versus concentration first. So remember, I'm going to highlight both sets of data, insert chart, and I want to create a scatter plot. And in my scatter plot, I want to customize it and make sure that my series has a trend line, which right away shows me this is not straight. But just in case, I want to put in the equation of my line and then show my R-squared value. So it's an R-squared value of 0.9, so it's okay correlation, but hopefully we'll get a better one than that. So I'm going to minimize that, put it here. So my second graph, I'm going to do time versus the natural log. So time, and then I'm going to do control click and highlight my natural log data. Insert chart. And I need to set it up so that it is a scatter plot. And then I want to put in my trend line. So I can see when I put that trend line in, this is not linear data, but let's double check. So I'm going to use my equation and show my R-squared value. So 0.97 is pretty good, but it's clearly not straight. So let's see if we can do better than that. So I'm going to minimize that one as well. And we'll do our last graph. Time versus, control click, 1 over concentration. Insert chart. Again, set it up for a scatter plot. This one is looking promising. Go to my series, put in my trend line. Wow, that matches pretty good. Let's double check though. So I'm going to use my equation for a label and show my R-squared value. So you can see my R-squared value here is 0.999, which is really close to 1. So this is going to be my linear data. So if I'm comparing my 3 charts here, I can see that of the 3, 1 over concentration versus time is the most linear. So I'm going to look back at my notes, and when my linear graph is 1 over concentration versus time, I know that this is a second order reaction. Okay, so now I want to focus on this graph to answer the rest of my questions. So my first question is, what is the order of this reaction with respect to the reactant, and how do you know? I know that it's second order reaction because the 1 over concentration versus time graph has a straight line with an R-squared value of 0.999, so that's pretty good. Okay, next is the form of the integrated rate law. So this is straight from my notes. I'm going to find the slide for the second order, and it is going to be 1 over the concentration at a specific time is equal to K T.
Attention students, if you are riding the buses, they are leaving shortly. Get yourself out to your bus, please, and study for your finals tomorrow.
Okay, so that's our integrated rate law. So what that tells us is that our Y data should be this 1 over concentration of NO2, and our slope is the K. Our X data is time, and then our Y-intercept should be 1 over our concentration, which in our data is 2, and that's right where it crosses, so that's good. Third question is, what is the rate constant? So according to our equation, K, the rate constant is equal to the slope, which is given to us in the equation of the line. So that is this value right here. So K is equal to 2.1 times 10 to the negative 4th Then we need a unit. So this is a second order reaction. So 2 minus 1 over ms for our rate constant. And then the last piece of it is what would be the concentration of NO2 at 2.70 times 10 to the 4th seconds. So given a time, what is our concentration going to be? So we're going to plug our values into our integrated rate law. So I'm going to do 1 over my concentration. That's what I'm looking for. So I'm looking for x is equal to my
Curiana Jackson, please go to
1
the dean's
times 10
office.
to the negative 4th times my time, which is, according to my problem, 2.70 times 10 to the 4th. And then plus 1 over my initial concentration, which if I go back to my data table, is 2. Or I can look at my graph and see it crosses at 2. So if I do my math here, I'm going to take 2.1 times 10 to the negative 4th times 2.7 times 10 to the 4th plus 2. So 1 over x is equal to 7.67. Now, I can't solve for an x that's on the bottom, so I need to bring it to the top. So I'm going to multiply both sides by x, which gives me 1 equals 7.67x. And then to get x by itself, I divide by the 7.67. So 1 divided by 7.67. My concentration, x, is 0.130 molar. Okay, so you're going to follow the same process, you guys, but you're going to do it with the Kinetics of Crystal Violet lab data. So you'll find that in our Google Classroom. Same process, same questions, and then there are a couple of conclusion questions that talk about the collision model. We've talked about it a little bit in class, and there's some on it in your book. So if you need more information, you should refer back to your book to answer those conclusion questions. Have a good couple days off.